on MATLAB programming. We have seen how we are going to handle indexing in MATLAB for the arrays. Now let us see some shortcuts, matrix shortcuts. There are two shortcuts, important shortcuts. One is called ones. This is the command. ONES is a command. Ones. ZE zeros. Zeros is another command. So we have two commands. The ones command that creates a m cross n matrix of ones. For example, if I write A is equal to 1, 2, 3, which means it is a 2 cross 3 matrix of 1. So you can see that answer is A is equal to 1, 1, 1, 1, 1, 1. Everything is 1, right? And it has 2 columns and 3 rows. So A is equal to 1, 2, 3. So 2 columns and 3 rows. Similarly, zeros, that creates m cross n matrices of zeros. For example, if I write B is equal to zeros 1, 5, it has 1 row and 5 zeros. So B is equal to 0, 0, 5 zeros are there within B, within bracket 2 I am showing, but you cannot, you may not use the brackets. MATLAB will not show you the brackets, it will show you 5 zeros. So this is a shortcut for two important matrices. If you want everything to be 1, so you can write it as 1. If you want everything, all elements to be 0, you can write it 0. Where you will use this? These are used as the initial elements, initialization. If you are using a product multiplication, you can start with initializing everything to 1. If you are doing a summation, you can start with initializing everything to 0. You know, in the summation operation, 0 is the identity number. Similarly, in product multiplication operation, 1 is the identity number. What is the identity number? Identity number means if it is multiplication, then if you multiply by that number, if you multiply any number by the identity number, you will get back the same number in multiplication. Similarly, in summation, if you add by that number the identity number to any number, you will get back that number, not the identity number, the other number you will always get. So that is how you define identity number. Similarly, there is another matrix which is called I, which is the identity matrix. In the I, if you write EYE within bracket 3, 3, then you will get a 3 cross 3 matrix in which all the elements are 0 except the diagonal element from left to right. The left to right diagonal will be 1, all other elements will be 0, EYE. That is for identity matrix. Now let us come back to the operations on array operations. Now let us say we have a row vector defined as x is equal to 1, 2, 3. So the vector x has 3 elements, it is a row, 1 row. Similarly, we have a column vector defined as y is equal to 1 semicolon 2 semicolon 3. So we have 2 vectors. Then we have another vector z which has rows and columns. In the rows we have 1, 2, 3. In the column next row is 4, 5, 6. Next column is 7, 8, 9. So it is a 3 cross 3 matrix. So what we have got? 1 cross 3 matrix, 3 cross 1 matrix and 3 cross 3 matrix. These are 3 things that we have got. Now suppose I write A is equal to 1, then colon mark 6, 1 colon mark 6. What does that mean? That means A will be 1, 2, 3, 4, 5, 6. A will be a row vector which has 6 elements, and these 6 elements are 1, 2, 3, 4, 5, 6. So it starts with 1, then gets incremented by 1, then gets incremented by 1. So this way it keeps on incrementing till it reaches 6. So A is equal to 1, 2, 3, 4, 5, 6. The same thing I can write as A is equal to within square bracket 1, then colon 6. So this shows the importance of the colon operator. So both these are same. Square bracket is optional. You may use square bracket, you may not use square bracket. and increment is by 1. Now suppose I do not want a 1 increment, I want more than 1 increment. I can, let us see this example. C is equal to 1 colon 3 colon 10. So here the first element is 1, then increment is the second element 3, and the final value is 10, which is the last element. So within bracket, that is I have shown first colon increment colon final, which means first is the first element, final is the last element, and increment gives you the increment value. So 1 colon 3 colon 10, first element is 1, it will be incremented by 3 for the second element. So 1 plus 3 is 4, then it will be incremented by 3 for the next element, 4 plus 3 is 7, and then it will be incremented for the next element, 7 plus 3 10. Suppose C is equal to 1 colon 3 colon 11, then you will find C is equal to, if in the command prompt you write C is equal to 1 colon 3 colon 11, in the answer will be C is equal to 1 4 7 10, because after the increment, after increment 10, now you reach 10, then the next increment will be 10 plus 3 13, you will never reach 11, you will always be at 10. Same thing, C is equal to 1 colon 3 colon 10. This is one way of writing or incrementing. Another way of incrementing is linear spacing, linearly spaced. Lin space means linearly spaced. Example is D is equal to lin space within bracket 1 comma 15 comma 4. This means the first one, then the final value, then total evenly spaced values. How many values you want evenly spaced between the final value and the first value. Now we have said here first value is 1, final value is 15, and we want 4 values. So these 4 values will be 1 and 15 will be inclusive of these 4 values. So it will be 1 and 15, 1 in the beginning, 15 in the last, in between 2 values. Those 2 values will be equally evenly spaced. So it will be 1, then 5, then 10, then 15. So it is 1, 5, 10, 15. So if you want to space evenly everything, then you can always use lin space, linearly space. So first value, final value, total number of space in between the first value and including the first and final value. Similarly, there can be log space. E is equal to log space 2, 4, 3. This means 2 is the first value, 4 is the final value, and 3 is the total values. This means 10 to the power 2, 10 to the power 4, 2 represents 10 to the power 2, 4 represents 10 to the power 4 because it is log, and 3 is the values between 10 to the power 2 and 10 to the power 4, including these 2, 10 to the power 2 and 10 to the power 4. So that will be 10 to the power 2 is 100, then 4 is 10,000, between them the next logarithmic value is 1000. So 10, 1000, then 10,000. Now let us take a test. The test is A1 is given here, A2 is given here, and A3 is given here. Now give me the answers. What will be A1? What will be A2? If I write that this line, then press enter. What will be the values for A1? What will be the values for A2? What will be the values for A3? This is a test, take home test, calculate it and let me know after the class is over. So these values are given. Please write this in your notebook and let us see what happens at the end. I will give you the results. Of course, some of these results I will show you. Now, where this is useful, let me show if these operations, array operations, where it is useful. Let me give you one example of graphics. In the graphics, it is very useful. You can see that the first one is x is equal to 0, then integral multiples of pi by 4, 0 pi by 4, 2 pi by 4, 3 pi by 4, 5 pi by 4, up to 2 pi. So this is what it is doing. So we have 9 values. Then y is equal to sin x, plot xy. You can see the plot. This plot we have already seen earlier. Now you can see the same plot this is not very smooth. This is a staggered plot. So it goes up to one point, then bends, goes up to another point, bends, goes up to another point, bends. This way that you can find 9 bends or 9 inflection points in the plot. It is not very smooth. Now, why it is not very smooth? Because the points are sufficiently separate from one another. If the points are sufficiently close to one another, then it is difficult to find the staggering. It will appear to be smooth, although in fact it is not smooth, but it will appear to be smooth because points are very close to each other. That is on the right hand side, which I have given as x linear space 0, 2 pi. So starting is 0, ending is 2 pi. Between 0 or from 0 to 2 pi, we have 181 points. So since we have discrete values, otherwise don't use discrete values, but that does not give a smooth curve. It is not eye-soothing. So now let us look to the operations. The dot operation. Dot operation means the element by element operation. And now what happens using dot operations is shown on the left hand side. In the top we are showing A is equal to A1, A2, A3. It is a 1 cross 3 matrix. B is again a 1 cross 3 matrix, B1, B2, B3. Then if I write A plus or minus B, that will result in A1 plus minus B1, then A2 plus minus B2, A3 plus minus B3. This is normal operation. If I write A dot cross, this is dot operation, A dot star, this here I am showing cross, but in matrix you will for cross you will put star. A dot, this will be A1 cross B1, A2 cross B2, A3 cross B3. As in the summation A1 plus B1 or minus B1, similarly multiplication will be A1 cross B1, A2 cross B2, A3 cross B3. If I write A dot slash B, it will be A1 by B1, A2 by B2, A3 by B3. This is always element by element. Each element is divided by or multiplied by the corresponding element of the other matrix. A dot crate 2 means A1 square, A2 square, A3 square. Whereas if you write A crate 2 or A hat 2, that is A star A. So multiplication of two matrices. This is square of each element of the matrix. Similarly, if I write A is equal to A1, A2, A3, B is equal to 2, C is equal to C1, C2, C3, then A dot B will be A1B, A2B and A3B. A dot C will be how much? You have to find out A dot C. Easily you can say A1 dot C or A1 cross C, A2 cross C, A3 cross C. A dot slash C, that way you can write, A plus C you can write. And now let us see an example. X is equal to 1, 2. Y is equal to 2 colon 3, 2 semicolon 3 semicolon 4. Now I write X dot star Y. Then you put enter, it will give you an error. Error using times. Times means multiplication. Why? Matrix dimensions are different. X is a 1 cross 2 matrix, Y is a 1 cross 3 matrix. So for operation, this operation to hold, dot operation to be hold, or to hold or to be correct, the matrix dimensions must be correct. Similarly, A dot slash Y will give you an error message. Error message always comes like this: 3 question marks, then error. Then using something. Using here R divide, right divide. R divide stands for right divide. Matrix dimensions must agree. Even if you write X plus Y, it will give you error using plus. Matrix dimensions must agree. So here dimensions are not agreeing, therefore you are getting error. Okay. And now let me give you an example. Here another example of this indexing and these errors what we saw dot multiplication, indexing, everything. Now here radians is equal to 0, pi by 2, pi, 3 pi by 2 and 2 pi by 3, 2 pi. So radians will have 1, 2, 3, 4, 5 elements. Radians has 5 elements. Degrees is equal to radians dot star 180 by pi, which means we are going to multiply each element by element, will be multiplying by 180 by pi. Means radians will be converted to degrees. So second line converts radians to degrees. The semicolon mark in these first two lines, they prevent the output of the result. On the command window, we will not see what is the result for these two. Then we write table. Table is equal to, within square bracket we have written radian comma degrees, which means we will write radian in degrees. We will write radians. So this is a mistake. Table is equal to radians, square bracket starts radians, then square bracket should end. This degrees will not be there. Either it will be radians or it will be degrees. Either of these two will be there. This is taking radians. So table is equal to, how many radians are there? 1, 2, 3, 4. So columns 1 through 5 will be 0, 1, 2, 3, 4. 0, 1, 2, 3. 4 values are there. 0, 1, 2, 3, 4 are right. There are 4 values. So columns 1 through 4, 0, 1.5708, which is pi by 2. Then pi is 3.1416. Then 3 pi by 2 is 4.7124. Then 2 pi is 6.2832. So this is the table. If I write table new is the radian dash. Radian dash means transpose of radians, comma degrees dash, which is transpose of degrees. Now since we have said comma, so the one will be a column matrix, the radians will be a column matrix, radians dash, which is the transpose of radians, is a column matrix. Then transpose of degrees is a column matrix. These two column matrix are placed as rows. Therefore first will be 0, so first row will be 0, 1.5, 3.1, 4.7, 6.2. Second row will be, second column will be 0, 90, 180, 270, 360. On the first column you find the radian. In the second column you find the corresponding degree. Converted, when you convert it into degree, the corresponding degree value is in the second column. So this is how you can use the dot product that we have seen. Then the formatting, simple formatting that we have seen. Now more on formatting is in the next slide. Shows you more on formatting. The leftmost column or the first column shows you the command. These commands you have to give in the command line or in the program, and what it displays is given in the second column, and example is in the third column. These F's in the command or in the first column, the first letter should be small letter. By a mistake it is capital letter, but first letter should be small. So format sort, which means we have got a 4 decimal digit. For example, it is 3.1416. So after decimal number we have 4 digits. That is what is 4 decimal digit. Format long, this is for pi. Pi is equal to 3.1416, you know. Then format long, this will give you a 14 decimal digits. So after the decimal point we have up to 14 digits. And format short E, this is the scientific notation, but 4 decimal digits. So there are 4 decimal digits, 3.1416 e to the power 0. Similarly, format long E, this is for scientific notation. Format blank, this is up to 2 decimal points, only real values. It shows only real values. If you have imaginary values, it will not be applicable. Format blank is not applicable in imaginary values. Then format short ENG, ENG for engineering notation. So for 4 decimal digits in engineering notation, it is like the scientific notation. Similarly, format long engineering, so it is engineering notation. Format plus or format minus or format blank, all these you can show. So plus, minus or blank. Example is plus, minus or blank. This is just before the number. We are saying 3.1416, that can be minus 3.1416. So there you can write format minus, then you write pi. So that will be this. Format plus, then it will show you plus. If you don't give anything blank, means only 3.1416. Then format RAT, RAT. This shows you the fractional. RAT is rational. So format rational, format RAT, fractional form 355 by 113. It will not give you the value. So it will not give you the decimal point, 1 point something. That will not. It will give what is the numerator and what is the denominator. Both will be displayed. Format sort G. This is the best format which will be selected by MATLAB. MATLAB will select the best format in the short form up to 4 digits. Similarly, format long G, MATLAB will select the best format in the long format up to 14 digits. And now, how to save your work? If you are writing something or you are writing a program, how to save that? To save data in the working directory means present working directory, you can always write in the command from pwd, that will give you the present working directory, or you can see, as I told you in the first two slides we saw where you are in. So present working directory, there you can find. So saving the data in working directory, to star means it can be anything. So you can write any name there, star.mat file. So if you are generating any data is to be stored in the .mat file, right? So save file name. For example, file name .mat is the file name. Extension is .mat. Name is file name. That you can write MATLAB learning, fast program.mat. Those things you can write. And then you select the save. Either this you can do. Otherwise, in the MATLAB window, go to the left top corner, file. From the file, click on the file. There you will find out the save. From the file pull down menu, then click save. So it will be saved. Reloading this MATLAB, whatever you have loaded or whatever is the data you want to reload it, then you can always write load, then file name. So in the command prompt you can write load file name, or in the program you can write load file name. Here I am writing file name.mat. Right. Otherwise you can go to the same file menu, open for the file pull down menu, then write open. Then once you write open, or then once you click on open, it will show you a list of files. Select the file, double click on the file, it will be loaded. So saving and loading is to be done in this manner. With this, we come to almost an end of our discussions. I will give you some exercises after this, and then we'll stop for today. The exercises are like this. I am going to give you some matrices. For these matrices, you have to do 3 jobs. First job is enter the matrices given in the next page. In the next page, I am going to give you the matrices. Enter the matrices to your MATLAB. Right? You can use space, commas, semicolons to separate rows and columns. As per your choice, you can use that. But enter these matrices. That is the job number 1. Job number 2 is use the who and whose function. After you have entered these matrices, then use the who and whose function to confirm that all of these variables and matrices in the workspace are present and they are correct. So use the who command, that will show you the names of the variables. Whose command, that will show you the values stored in those variables. Compare that with what you have entered. Then change the highlighted elements in each matrix. Now let us see the matrices that we want to give. On the first matrix, A is equal to 1, 5 is highlighted, then 11, 3, 7, 16, 7, 5, 8. 8 is highlighted. It is a 3 cross 3 matrix. 5 and 8 are highlighted. B is equal to 1, 8, 37, 61, 92, 91. 37 and 92 are highlighted. C is equal to 13, 31, 61, 16. 13 and 61 are highlighted. D is equal to 37, nothing is highlighted here. E is equal to any 9 cross 5 matrix of 1s, or any 9 cross 5 matrix of zeros, or any 9 cross 9 matrix which is an identity matrix. E can be any of these three. I am writing here is of 1. You can make it zeros or make 9 cross 9 or a 5 cross 5 identity matrix. Then F is equal to 7, 11, 131, 49, 55, 23, 67, 12, 43, 34, 66, 8, 0, 81, 23. This is a 4 cross 4 matrix in which 11, 12, 66 and 0 are highlighted. So these highlighted values are to be changed. You have to change these highlighted values using the indexing. So from which we will understand how much you have understood, or we will know how much you have understood in this indexing. So these are something that you have to practice. Practice this is in your home in free time, and we will discuss on the results in the next class. So with this we come to the close of today's class ends here. Today's discussion ends here. Formal discussion. Informally we can continue to discuss.